In this video, I will show you how to add data to the BYU Tethys GeoServer, which is currently located at tethys2.byu.edu/geoserver. And the goal of this server is to be kind of a central GeoServer for all of the Tethys apps to use that are developed by BYU. We'll be using a file browser web application that's also on the Tethys2 server to add files to this GeoServer. The nice thing about this is you won't need SSH access or credentials to get on the server itself to add the data. You can just upload it through this Google Drive-like interface. Before I continue, I just want to put a plugin for the Spatial Dataset Services API in Tethys. This allows you to add files programmatically to GeoServer, including things like shapefiles, geotiffs, and common data sets, and expose them as web services. So if you want something that's more automated, that your app can add the data manually or automatically, you'll want to look into the Spatial Dataset Services API. However, some apps just need a couple of files of data to serve as kind of background data layers or things like that. And so a manual upload is appropriate for those. So the first thing you'll need to do is actually go into the GeoServer web interface and create a new workspace. So the workspace that I'm going to create, I'm going to call Utah Data. I have several data sets that are comprised of Utah shapefiles, Utah geotiffs, and netcdfs. So we're going to call it Utah Data. The namespace URI just has to be something unique. Oftentimes people just put this, the same thing as the name, as long as it's unique. URI kind of indicates a URL type thing. So often a reverse URL like edu.byu.tethys.utah-data might be appropriate. Doesn't really matter as long as it's unique. Go ahead and press submit. And if we search our list of workspaces here, we should see our new workspace. Okay, great. So now if we go into the Files app, you can see these folders here. These correspond with all of the workspaces in the Tethys GeoServer data directory. So if we scroll down, we should see the Utah one. I think what I need to do is actually refresh. There it is, Utah Data. And it's got a couple of XML files in here. These XML files kind of define the workspace for GeoServer. I would not recommend messing with these unless you know what you're doing. What I would recommend, though, is creating a new folder called Data right here in the workspace directory. And then here we want to upload our files. So there are a couple of files that I want to upload, and actually they're folders of files. So first, I'm going to go back and navigate to this Utah County Boundaries folder and upload that. This has a shapefile in it, which is actually several files if you're familiar with shapefiles. Then I'm going to go back here to the 1 meter LiDAR data set, and I'm actually just going to select this 1 meter LiDAR folder and upload it. And then finally, I'm actually going to create a new folder called Utah Groundwater, sorry, GW for groundwater. And in here, I'm going to upload just one file. So what I want to do is go in here. These are some groundwater netcdfs that I ripped off from one of the groundwater apps. And they're quite large, so I don't want to upload them all. I think this file is 1 gigabyte. So it'll take just a minute to upload. While that's uploading, we'll go ahead and continue with getting our other data in place on GeoServer. So I'm going to go back to GeoServer. Now that the data has been added to the data directory, I can create stores. A data store or a coverage store in GeoServer is basically just a connection to a folder, a file, an SQL database, wherever the data is stored. So I'm going to create a new one And let's go ahead and start with our GeoTIFF. So I'll select that and go find the workspace that I just created. And I'll just call this 1 meter LiDAR Utah. Then I'll browse. This will drop me in the data directory of GeoServer, so I'll go to Workspaces, go find the Utah Data Workspace, Data, that directory created, 1 meter LiDAR, and I'll just go and find the TIFF. And press Save. Okay, so that creates the data store. In order to publish the data as a layer on GeoServer, we need to press this Publish link. There are a few things that you need to make sure are filled out here. The metadata is filled out as it needs to be. I guess the one thing we might change is it picked up the name of the file, so maybe we want to call that 1 meter LiDAR Utah, like our data store. And do that for the title as well. But the important things to add here is to make sure that it picked up on the coordinate system and that it has the bounding boxes here. It looks like it read these just fine from the GeoTIFF, but sometimes you need to define these manually. So that looks good. Last thing, I go to the Publishing tab, and I want to make sure that I have a good set of default styles assigned. So there are a few built-in styles that come with GeoServer. This raster one should be fine. There's another one called DEM that I will add. It's another raster style. And we'll go ahead and press Save now. To verify that this is working, I'll go to the Layer Preview and search for our workspace, Utah Data. And this Open Layers link will actually provide you with a preview in an Open Layers kind of mapping thing. And if we zoom in, you can see it's actually pretty high resolution, I guess. It's hard to tell without the context of the map. And you can actually query individual cell values using the Get Feature Info implementation that GeoServer supports. So that's looking good. Interestingly enough, if I look at these options here by pressing this dot menu, it's selecting the default style. The DEM style actually doesn't work on this very well, so that's okay. You ideally would want to create a custom style for this layer or set of layers that you're working with, but we won't cover that today. Let's go back to GeoServer and process our shapefile this time. So again, we'll go to Stores, add a new store, and go to Shapefile. And then select our workspace just as before. Give it a name, Utah County Boundaries. And not to be confused with the boundary of Utah County, I'm going to put a description here. Features of each county in Utah. And I'm going to browse once again and go find that shapefile. So workspaces, Utah data, data, Utah County boundaries, and there's my shape. So I'll select that, press save. One thing to point out before we proceed, if we go look at this, it's not just the shapefile that's in here, it's all of the supporting files as well for the shapefile. So just make sure you have the PRJ, the SSHX, the DBF, make sure they're all in there. Okay, so we'll go back and press publish again. Now this layer had an issue with figuring out what the spatial reference system is from the file. If we look at it, it is WGS84. So what I'm going to do is just pick the standard WGS84, which is 4326, I believe. Yeah, so I'll select that. And then We have to manually click the compute from data and compute from native bounds. And then notice, because it is vector features, there's actually a table of properties that each feature will have, just like in the shapefile. And once again, go to publishing and just make sure there's a good default style here. The polygon one is fine. So we'll leave that and press save. Let's go verify and layer preview again. We'll search for Utah data workspace. And you can see the 2 layers are here. So Utah County boundaries. And here it is. And once again, we can click on the features and get those property values for each county. Okay. Very good. So I believe our 1 meter LiDAR, or sorry, not 1 meter LiDAR, I believe our NetCDF finished uploading. So we'll go ahead and add that one now. Go to stores, add new store, and locate NetCDF under the raster data sources. Find our workspace, give it a name, groundwater, and go browse to the file. Workspaces, Utah data, Utah groundwater, and select that file. Notice it pulled out LWE thickness. I think that's a variable inside this NetCDF. So we're going to go ahead and publish that. And again, we just need to check that it pulled these in. Looks like it got the coordinate reference system, the bounding box, although the bounding box is a little goofy. We'll just leave it though. And then if we go to publishing, raster layer, I'm going to add DEM again. Press save. And then we'll go to layer preview and verify. So here's our LWE thickness, preview and open layers. So you can see it's got a weird bounding box. You can vaguely see the shape of Utah in there. But it's hard to see because the no data value is not represented appropriately. We could go tweak some settings with the layer, but I found that just looking at it with this DEM style seemed to work okay. The one thing is that it doesn't have the proper breakpoints. So it all looks the same color more or less, but if we click around, you can see the values are varying. So what we'd want to do is go in and create a custom style that's maybe based on this DEM one, but has custom ranges. So, but again, that's kind of out of the scope of what we're doing today. So that ties up the tutorial for adding data to GeoServer. I guess one last thing that I'll point out, if we go back to this Utah data workspace directory, you'll see that there are 3 new folders in here, 1 for each of our data stores. And if we look in those, you'll see more XML files, and then a folder with the same name as our layer, and more XML files. These are things that GeoServer requires to represent layers and data stores. So again, don't mess with them unless you know what you're doing. And it should be fine. Good luck with adding data. Hopefully this tutorial is helpful. Have a great one.